So far in this chapter, we have been finding limits using tables and calculators and graphs. In this section, which is titled Algebraic, Limits and Continuity, we will find limits using analytical methods. In other terms, we are going to do the math without using a calculator, without using a graph, without using tables. We will find limits using some of the formulas that are written down in front of you on this particular page. These formulas about adding, subtracting, multiplying, and dividing, and finally the constant multiple rule. So let's go through these real quick and try to understand what each one of them is saying. So for example, the first one is saying that the limit of a constant is always that constant regardless of where x is going to. So for example, if somebody were to ask you what's the limit as x approaches 3 of the number 5, your job is to say the number 5. Regardless of where x is approaching, the height of the curve is always going to be 5 in that situation. Now, the second rule in the list says that the limit of a sum is the sum of the limits. So in other terms, if somebody were asking you, what's the limit as x approaches, let's say 3, of x squared plus 5, then you would say this is the limit of x squared plus the limit of 5 as x approaches 3 and as x approaches 3 again. So it just gives us a way to break the limit problem into multiple pieces. And by the way, this formula works even if you have a minus. So if you have x squared plus 5 or x squared minus 5, you would just get the same result on the other side also. It's the same. Next, we have the limit of a product, which is the product of the limits. So this is similar to the addition and subtraction formulas that we just mentioned, except it allows you to have a multiplication inside rather than a plus or a minus. So again, this works the same way as the previous rule. And similarly, this next rule about division also works the same way. The limit of a fraction is the fraction of the limits. Finally, the last rule on the list is the limit of a constant times a function. And the rule says you can ignore the constant and just find the limit of the function. So all these rules are here to just say that limits are very intuitive and they work very, very beautifully. You don't have to really worry about crazy mathematics here. It's just very simple stuff, okay? The next theorem basically says that the limit of a rational function is the function with the number a plugged in. So for example, if I was to ask you, what's the limit as x approaches 3 of x squared plus 5 divided by x? So since the inside is a rational function, the rule basically says just replace the x's with the number that you have in the limit. In this case, the number is 3, and just estimate the value there, and you're basically finished. So again, limits are supposed to be very intuitive, very basic. Basically, all we're going to be doing in this section is taking the number underneath the limit and then plugging it in for all the x's. That's basically how we're going to do it. And 99% of the time, this is going to work, and it will be the end of the problem. There's a couple situations that will not work, and we'll talk about those problems in a few minutes in another video.